The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Problem number 16. 16 states, two sinusoidal waves have the same angular frequency and same amplitude, Ym, and travel in the same direction in the same medium. But if they differ by 50 degrees, the amplitude of the resultant wave is given by what? So, we have sinusoidal wave 1 and wave 2. Same angular frequency, same amplitude, same direction, same medium. Whole lot's the same, but they differ by a phase angle of 50 degrees. Visually, this is what it means. We have wave 1. Wave 1 is the solid line, wave 2 is the dotted line. Okay? So wave 1 is going like a regular sinusoidal wave. Wave 2, here is pi, the point at pi, and here's 2 pi. 180 degrees, 360. Here's 90 degrees. So 90 degrees is just over halfway to 90 degrees is where 50 degrees is at. So if wave 1 starts here, wave 2 starts here, and as you see, it goes with it. Now so they end up adding together at certain parts. This is added onto this wave in the amplitude version. So really it would be going duh, 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 and then all of a sudden it'd be continuing to rise and then fall, so that it would be, that's what interference is, constructive interference. They add to each other. Now, how we solve this problem? We use an equation dealing with amplitude. You're given the equation for when you have two waves that interfere with each other. You're given this equation. The new Ym is equal to 2Ym cosine 1/2 phase shift times sine kx minus omega t plus 1/2 phase shift. Okay? This equation has a whole lot of information in it, and we're not given that much. We're only given one number. So that's got to signal something to us. Now, if you see this equation, you should be able to realize that this new y max, how this is dealing with it. How this equation is dealing with it. This part right here is dealing with other parts of the graph and not the amplitude. It doesn't really affect it doesn't really have an effect on this new amplitude. It's dealing with other points on the graph, not the amplitude. That's just the basic kind of, I don't really want to go into explaining that more because it'll just complicate things. And it's just complicated. Just, you see that Ym is here, Ym here, Ym here. This is what you need to focus on. So, now we have this new Ym is equal to 2, so X that out, 2 Ym cosine 1/2 of the phase shift. Alright? So now we know now we can plug in what this phase shift is. They have the same Ym, so really the only thing we need to do is change that up, and all of a sudden you have Ym is equal to 2 Ym cosine of 25 because phase shift is 50. And that, sure enough, is the answer. This equation, these kind of test questions dealing with amplitude and interference of waves look complicated. They do, and solving them is to figure out, there's almost always, in terms of a test question, there's almost always a whole bunch of stuff that is irrelevant. You don't need to worry about it. They're really focusing on one thing, and they want you to be able to identify what that one thing is so that you can cancel the rest out. As you see, it becomes quite simple once you realize that this isn't going to affect it. You just need to focus on this. Okay?
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.